Hi, I would like to mount this breadboard to this underboard using these pins. So these holes should be 5mm, but also they are not quite outlined to these. They are a little bit more together, smaller. So what I did, I made a plastic interface with the right distance, and I mount the breadboard on this plastic, not mounting but fixing it temporarily with some tools, and then I drill a 5mm hole in it. I then fixate the breadboard by hand to these holes. It is a little bit tricky, and then I tied it very fast with this tool, and then I drill it by hand because I don't have a drilling machine, a fixed drilling machine that can handle 5mm. I think I'm gonna buy me a drilling machine that can do that, because now look what happens if the drill is too sharp. Sometimes it goes well, other times it's just a disaster. The last two contacts are damaged. I just get them out, and remember, don't use those last two connections. I then cleaned it up, and then I can fix these pins into it, and I can mount it on the board with the holes. Well, I finally succeeded, but look at the underside. The pins are not straight, because drilling by hand makes the drill follow the existing hole. Unless we use that template, you can see that the upper side is not nice. I do not like this, but anyway, it's usable for now. I like to use these pin headers, two of them, solder a wire to it, instead of using this brown lead pin, because this makes less good contact. It's about 1 ohm or more, and when you move it, the resistance shifts, and if you do it this way, it's very solid connected to the breadboard connections. When soldering, I use this stack of PCBs to put the pin header in, because if it's in here, it's connected to a larger piece of metal and it will solder less easier. So I always use this one to solder. Sometimes when stripping these wires, and I'm used to solder it at about 360 degrees, it will oxidate and it will not fit. So I reduce the temperature to about 250 degrees Celsius and then solder this wire. It may also depend on the material of the wire. The black wire has a silver color and the blue wire has a copper color. Finally, I managed to solder them all three. So now we can test this transistor, a hvw202412211512. Yes. You can see I even mount those transistors to components on a PCB board to make a better contact with the breadboard. Now let's try and measure. It's curious what it's saying. It's about 374 HFI. 373. The difference between the current through the basic and the current through the collector. I didn't get on the name, but it is called the gain factor. Here the transistor is mounted on the breadboard, Unfortunately, I use here the old method, not the new one, to make it stable. But anyway, with a gain factor of 373, with 10 microamp base current, collector current should be this, 3.37, 20 microamps base, the collector current should be about 7.5. So we start with the multimeter on 1.2 volts, full swing resistor, nothing happens. I make it up to 1.3, 4, 5, 6, 7, 8, 9, 2 volts. And if we draw it back to 20 milliamps, the left meter, 20 microamps, about this, the collector current should be 7.5. You can see dependence on accuracy of these meters. It's more than 8 milliamps, so the gain is a little bit higher, maybe on the lower voltages. I draw the current back for sure. Security, I go to 3 points. 2.1, 2, 3, 4, 5, 6, 7, 8, 9, 3 volts to make a robust measurement. 3 volts, I go to 20. You can see it's also the same points. Now we go to 4 volts. Go to 20 milliamps, microamps. And it's a little bit, now there's something, that's the bad connection thing, or the potentiometer is not correct. But you can see the gain is going up. So maybe if I look at the data sheet, this is an old transistor. It's a 184 and the gain should be between 110 and 800, the HFI. So this, I don't know what level and what voltage this measurement is executed, but probably at a very low voltage. I can go back to the lowest voltage, say 1.4 volts. Let's have a look if it should be more, otherwise there is no deflection. So I have 6, 7. Okay, let's this is 1.8 volts. We go set it on 20 microamps. Oh, that's not possible. I have to go up 1.9 volts. Now is the multimeter of 10K is in series with another 10K, and in the middle the base is connected. But still we have, depending on the accuracy of the meters, a gain of more than 373. It's about 400 and a little bit extra. But anyway, interesting experiment. I would like to explain something. And here I made another video of this, I think in Dutch, and this was also a micro ampere meter, but because I didn't have a milliamp meter, so I made this video again, but in English, although my Dutch English. This is the schematic. There are no other resistors or whatever involved, only a divider. 110K is this one, and the other, of course, is the variable resistor, the transistor, and I forgot the meters. Here's the collector meter. I don't know how to draw it with it. And here's the base meter. The base meter is this one. The collector meter is this one. And of course, a transistor is an N. This is an NPN. It conducts only if the voltage between the base and emitter is 0.6 or 0.7 volt minimum. And of course, this is a voltage divider to make at least 0.7 volt here, this must be 1.4 voltage minimum before the schematic will work. So this is some extra information. And I forgot to tell, of course, this is the variable voltage source power supply. Thanks for viewing. I would like to give some extra information on the wires I use. I made this wire, stripped it and soldered it to this dual pin header. This one is coming straight from above, this one also from the side. But I didn't realize that if you bend it, it only is connected with the inner core to the connector. So bending it a few times, it will break off. Better you use the original ones, the cable complete, and then solder it to this dual pin head. You don't misuse the inner instruction. The connection between the inner core and the outer mantle is still complete. So this will last very long. If you move the wire, it won't break off very soon. So that's the new principle I will use, and not only one pin but two pin for stability.